Hi there, hi everybody. I'm here to tell you about nanotechnology and its wonderful applications. But what do I mean by nanotechnology? Nano? Does anybody know what that means? Well, think of a meter. How big is a meter? Look, it's a meter. It's about this long. But when you get down to a centimeter, it's about that size. A millimeter, even smaller. But when we talk about nano, we mean a billionth of a millimeter. We're talking about atomic scale, atoms. And when we get down to that size, in the macro world, you've got big tables, bottles. But when we get down to the tiny little things, structural properties change. Chemical properties of atoms change. Say, for example, gold. It's an inert metal. Nothing happens, just lying there looking expensive. When you get down to the nano scale, and a ball of gold atoms will spontaneously combust, blow up right in front of you. But a good application of nanotechnology is looking at surfaces. You think a surface is very smooth like this table? But when we get down to the nanoscale, we see all the atoms aligned like so. And all these atoms individually have bumps in between them. So how can we look at this? What we do is atomic force microscopy. This might sound very complicated to everybody, but it's very simple, believe me. When we look at atomic force microscopy, what we do is we get a little pin and we traverse it across the surface like so. And we can measure how the diameter of the atoms and how far apart they are. So take for example gold. It's a very flat surface, but when you get down the nanoscale, it's very, very bumpy. And what we can do with atomic force microscopy is, here's a clever part, we traverse a pin across it. And here's the clever part. We fire a laser at the top of the pin, which goes into an array of photodiodes. Now you don't know what a photodiode is. But it goes into an array of photodiodes and creates a picture on a monitor. And when we create a picture, we get a surface topographic image of it. You can see all these individual atoms moving about. And a great application of atomic force microscopy is also atom manipulation. What we can do is, when we have these atoms all aligned and we traverse the tip across, we can apply a charge to this tip. Because say for example gold, it's a positive, it has a positive valency per atom, meaning that it's positive, When you apply a charge, it's negative. So what we can do is pick up individual atoms as such and drop them in other places. So we move things about on the nano scale. And when we can do this, we can create pictures that no one can ever see, but pretty enough they are. And things like this have applications. We can create dynamic structures, even motors. Eventually, it's in the process. But we can create motors, and it's great having an application like that because we can develop it in the future and hopefully create tiny little nanobots.
Okay, thank you very much, Jacob.